Thresholding, this is the simplest way to segment an image. So this is what a lot of people use to separate their objects from the background. In order to threshold your images, ImageJ, or in this case, FIJI, that's what I normally use, bases the calculations on the histogram of the images. So basically, you want to look at the intensity levels of images. So for instance, you have an image like this. This is an image of gold nanoparticles. So in order to separate out these nanoparticles from the background, if you want to measure, for instance, the total intensity of your image or the percentage of area occupied by these nanoparticles, you want to be able to separate this out from the background. So ImageJ, as I mentioned earlier, uses the histogram. So if you go to Analyze and Histogram, you will see a bimodal distribution of the pixels that are incorporated in this image. So you see at the left side of the histogram, you see a peak here, which represents the background. So in this image, this part here is this peak here. The peak at the right side represents the number of pixels that are present for the objects. Okay, so this part here represents the histogram of the objects or the particles. Now, in order for you to threshold your images, I'm just going to put the histogram to life. You go to Image, Adjust, Threshold. Okay, oops. Let me just click on the image, Adjust, Threshold. Okay, so immediately you're going to see the particles that are thresholded in red, because that's what I chose here. You can choose a different color, either it's in black or white, and over under. Okay, but the important thing here is that you can see here this rectangle. This represents the objects that are actually thresholded in the image. And you can see it here in the histogram as well. Now, when you change the threshold value, so let's say you go to a very low threshold, you'll notice that part of the background is included in the thresholding. Okay, so when you take measurements, whatever is red will be part of your measurements. Okay, so if you're using a very low threshold, the tendency is that part of your background is actually included. You can see it here as well. If you change the threshold to a very high value, you only tend to take measurements from a limited number or a small amount of or area of pixels in your objects. Okay, so using this manual thresholding tool is not always the best way to go. Okay, there are different automatic thresholding schemes that you can see here. So we have the default, and every thresholding scheme here manipulates where the threshold is actually located in this bimodal distribution. So if you choose Wang, for instance, you see that the threshold changes. If you choose mean, that also changes the threshold. Okay, so what kind of threshold are you going to use? That really depends on your images. So there is not one best universal threshold to use. But if you use Otsu, for instance, in one image, I would recommend that you use Otsu for the rest of your images. That way, the calculations will always be the same, okay? So once you have thresholded your images, the next step there is to measure these images because this is already a segmented image, okay? So you can do an analyze and use measure, okay? Unless you want to change, you know, some of the way the thresholding was done, and that is by creating a binary mask. So when you click on apply on the image, that changes this image into a binary image. Binary in the sense that now you will only have two values, 255 for the objects that you want to measure and 0 for the background, okay? So let me just continue with the next part. Okay, so usually if you have images, thresholding is not always straightforward. So you would usually have to pre-process your images in order to get a proper threshold. And that involves trying to improve the signal to noise ratio of your images, to remove some artifacts, and maybe to correct background levels. Another one, of course, once you have done this, you can start thresholding your images with any of those automatic thresholding schemes. And then you can create your binary mask. After you have a binary mask, you can do some cleanup. And so that would improve your mask so that it's easier to do some measurements on the binary mask. So you do this using some morphological operations. After that, then you can identify your objects by setting your measurements and then analyzing particles. This is for two-dimensional images, okay, where you have regions of interest or ROIs that would identify those objects. So let's look at another example. So let's say you have an image that looks like this. This is a bright field image, okay? And clearly you can see that the background is very uneven, okay? So thresholding this image is not going to be very easy. So if I go to image adjust threshold, you'll notice here that not the particles that you want to threshold are actually not the ones that are chosen here, okay? And that's because it's choosing the background. If you take away that dark background there, because our background is light, you'll notice that even part of most of the background is considered as an object here. So that's why you have to do some pre-processing on this particular image first, okay? So let's reset that, okay? So if you hover your mouse over the background, you'll notice the values of the background here. In this case, you have a value of about 150s, okay? Then if you hover your mouse over your object, you'll see that the object intensity is actually less. Now, when you threshold your images, and if you want to identify these objects as your true objects, then you would want to probably invert this image, okay? So that the background will have a lower intensity compared to the objects. Okay, so what I usually do is to duplicate the image that I currently have. That way, if I make a mistake, I always have the original image there, okay? So you'd go to image and then duplicate. You can change the title or the name of that duplicate if you want, and click on OK. Right. So the first thing you want to do for this image is to invert it. Okay, so you would go to edit, invert. Now you see an object here that has a higher intensity than the background, but still your background is very high. Okay, so in order for you to threshold it properly, you want the background to be like really low so that there is a better contrast between your objects and your background. So you'd want to do some background subtraction. So go to process and subtract the background, okay? So in this case, we're gonna use this rolling ball radius, And the radius that you want to choose would be the radius or the size of the biggest particle that you want to measure. And in this case, it would be about 10 pixels. Okay, so I put 10 pixels here. You can actually preview what this rolling ball radius would do to your image. There you go. Now you can also choose any of these parameters here, like using a sliding paraboloid. However, this doesn't give you, as good of a background. So I will just, take that out. And then once you click on OK, you'll notice that the background now is much lower. Okay. So now we can apply one of our thresholding algorithms. I can just click on auto since it's set at auto right now. Okay, now the background is darker, so I'll have to check dark background. Okay, so this is the thresholded image. Okay, now if you find that your threshold is good enough for you to be able to, let's say, count the bacteria that's present in your image, then go ahead and click on Analyze Particles. But if you need to adjust, make some like morphological operations, such as separating out this thresholded values here, then you'll have to convert this image into a binary image, okay? And the best way to do this, instead of clicking on apply, which will convert this whole image into a binary image, I would use edit, selection, and then create a mask, okay? So that way I can restore or reset this threshold and use this to make my measurements. Okay, so if you zoom in on the image, you'll see that there are certain pixels that might be out of place. Okay, so there are errant pixels there. So if you want to remove those particles, what you can do is go to Process, Binary, and these are all the other morphological operations that you can do. Okay, I'm going to do this open here, which is basically a combination of erosion and dilation. Okay, so if I click on open, you'll find that those errant pixels are gone. Your next step would be to do a watershed segmentation so that you separate out these particles that are, considered as just one object. So you would go again to Process and then Binary, and then you would go to Watershed. And you would immediately see, the lines which would separate this out. Now, it's not perfect. The segmentation will always depend on what kind of threshold you choose, okay? So like in this case, for instance, you don't have a division there, okay? But just for demonstration, okay, we'll just use this, okay? So the next step, of course, would be to set your measurements, okay? So you would go to Analyze and Set Measurements. This way you can choose which parameters you want to include in your measurements. So if you want to calculate the area of each bacteria that you have there, you can calculate the area fraction. This is a bright field image, so calculating the mean gray value is probably not a good idea. Okay, so I would probably use this fit ellipse or maybe even the perimeter. Okay, and then you can check this limit to threshold. Okay, there's this redirect too. So when you want to make your measurements, especially when you're doing like intensity measurements, you want to redirect your measurements to your original image and not to the mask that you have here. Otherwise, your measurements will only be 255 or 0, okay? So you can choose which image you want to redirect your measurements to, okay? I'll just choose none for now, okay? So I'll click on OK. Now we want to go to Analyze Particles, okay? So here, under the size, you can set a range of measurements. Okay, so if you don't want to include very small objects, you can set a limit, the minimum, and if you want to include only a certain, size, the largest size, you can also set a maximum there. Okay, circularity is, if you're measuring different shapes, if you choose a circularity of 1, you will only be choosing circles. Okay, and so you can set this up as well, showing other stuff here like additional outputs. Okay, so since I'm looking at bacteria, maybe I can show the ellipses that were created. Okay, there. And I can choose to display my results. But here I'm just gonna do summary and add my measurements to an ROI manager. Okay, you can also select to exclude edges, the edges here that are not complete. Okay, or not. Okay, and then you can click on OK. So what you see here as part of your summary would be the count. So how many bacteria are present in your image? So we have 606. The total area, so all the areas combined gives this total area, the average size. Now this size here, the unit will be in whatever unit your image is. If it's spatially calibrated, it will be in microns. If it's not calibrated, it will be in pixels. The percentage area works on the thresholded image. Okay, so you'll be able to get the percentage area there. And then this one here, of course, is like the average of your ellipse, like the major and minor axis, including the angle. All of these can be saved. Okay, this is the output that I chose. So you have the ellipse there. And this is the ROI manager, the ROI manager, which shows us all the labels. I can take out those numbers there, right? All of those 606 measurements. Okay. Now, as I said earlier, you want to take your measurements not on this masked image, but on your original image. So if you don't want to get it from the inverted image, you can get it from the original one. Okay, just click on show all, and you will see now that your objects are highlighted. So each region here, you can click on measure, and you get all the measurements that are included as part of your parameters that you selected here. Okay, all these measurements can be saved, and you can do additional analysis on them. Or if you just want to look at one particular area, you just click on that, and that would be this particle. Okay, so that's the ROI manager. This is very helpful because you don't want to take measurements from your mask. I repeat, you want to take measurements from your original image. And if you want to take like intensity measurements, of course, it's best if you do it from the background subtracted image as well. I'm just going to delete everything here. Okay. And let's go on to the next part. And that would be on thresholding Z-stacks. Now I'm going to show you a few methods of thresholding your Z-stacks. One is the 3D objects counter, and then 3 others are part of the 3D suite. Okay, so if you have FIJI, all you need to do is go to the manage update sites when you update FIJI, and then you would need to check the 3D ImageJ suite. Okay, and then you'll be able to see all of these here. Okay, so let's open a Z-stack. Go here, there. All right, so if you have a Z-stack, this is a multi-channel Z-stack, okay? Here. The first thing that you want to do if you have a 2-channel image or 3-channel image is to split your image, okay? Because you want to do your measurements on separate channels. So you go to Image, Color, Split Channels, okay? So once you have split your channels, you can now select, okay, which one do I want to use? So in this case, let me just use the nuclei here, okay? If you look at the thresholding scheme here for a 2-dimensional image, okay, I'm just going to click check auto here. Since this is a Z-stack, you want to do global thresholding on the stack of images. So you want to use the stack histogram to look at the value that will be used to threshold your image. And in this case, it's found to be 60, okay? Now the auto threshold is similar to the default, okay? Because this uses the variance in intensities in order to calculate the threshold. So default, yeah, there, okay? However, because this is a Z-stack, I wouldn't use the analyze particles command, okay? Just because when you use analyze particles, although it will put everything on the ROI manager, it will count a particular object every time it appears in a slice. So that's not true 3D labeling, okay? So what you want to do is something that will segment your images correctly, okay? And that, and what I'm gonna show you first is called the 3D objects counter, okay? For the 3D objects counter, there are options here, 3D objects counter options, which allows you to select the parameters that you want to measure. Okay, so you can just go ahead and check whatever parameters you want. And then this would be whatever maps you want to show. And you can choose this later on. Okay, and then results tables, and then it also has a redirect too. Okay, I'll just put none here. Okay, yeah. But if you only have, if you want to do measurements on your original image, always redirect to this. Okay, now let's go to 3D objects counter. Okay, let me just cancel this. There, okay. So if you notice that the threshold that is automatically chosen is like the default global threshold in the stack histogram earlier. So that's how it automatically chooses the threshold. Now, of course, you can always change this threshold, okay? But that will be doing it manually now, okay? And then you could choose your slices this way. You can set the size. So this is the minimum size that you want to include in your measurements. Okay, so if you choose 4, this is in pixels, by the way, then any pixels, any objects that are, 3 pixels and below will not be included in your measurements. Then you can put a maximum here. This very high value just means that everything else will be counted, okay? You can show these maps here, so you can show the objects, okay? And then you can show a results table, statistics and summary. So if you click on OK, you'll see that it's going to renumber your structures, and you'll see the statistics here, which will include with values all those measurements that you check. And then the rest of the parameters that you didn't check earlier would be zeros, okay? So you'd be able to get the integrated densities, the means, and the volume, okay? Now, this is the objects map. As you can see here, you have the different objects labeled in different colors, okay? This is called the label image. So there's, each of these objects have a particular ID, okay? An ID which will represent this particular image. So your background will be 0, then all the others will have a particular value there. Okay, now, all right. Now, what if I want to look at the different regions here? Clearly, the object counter does not do that. So what I want to do is I'm going to use the 3D image suite, okay, in order to open up the 3D manager. So once this is added in your update site, the 3D suite, you're going to see this 3D manager, including some options here. The options would be, again, the parameters that you want to measure. So let's just go ahead and click on 3D manager. Okay, let me just go here. All right, so this object map here is already a segmented image, okay? So it already separated out your objects from the background. So all you need to do is to add this image into the 3D manager. Okay, now you can see all of these objects here. There's a live ROI here. I'll just click on it to turn it on and then select all of my regions. So immediately you see the regions are highlighted. Okay, so you can do all of these measurements here. These measurements, of course, you have this tool here. If you forgot to set the options, you can always click under settings. And then you can check the settings or the measurements that you want to include. Okay, including distance between pixels to split objects. Okay, I'll just keep whatever is in default there. And then do measure 3D. Okay, when you click on measure 3D, you're going to get the volume measurements of each of your objects. So we have several objects there. Each of them have volumes, volume in the unit that you have, which is in microns for this case. And then you have also the volume in pixels, okay? There. Now you have this quantify 3D. This one would include the rest of the measurements that you have. And in this case, I have the integrated density and the mean intensities, okay? There you go. But again, because these are mean intensities, I don't want to take my measurements from this original image or from the objects map. I want to take it from my original image. So I just deselect that. I want to apply my regions here. Select all of them. There, okay? Or if you just want to look at just one particular object, okay, let me just uncheck that. Let's say this one, okay? So if you look at this, you'll see this region here. And if I zoom in on it, okay, as I move from one slice to the other, you'll see that the region changes, right? So that means it's incorporating this or using this as a single object, right? So it counts it only as one object throughout the slices. Okay, so if you click on measure 3D, of course, you'll get one measurement. Okay, now there's this 3D viewer, which allows you to see how this object looks like in three-dimensional view there. Okay, and of course, if you want the whole image, of course, you'd select all of these objects into the 3D viewer. Okay. Now that's for the 3D objects counter. Now I'm going to show you another way to segment your images. Okay, I'm just going to delete everything here. Okay. Okay, so the other two ways to segment your images would also be under this 3D ImageJ suite. Okay, so 3D suite. And then, so under segmentation, you're going to see a lot of other thresholding schemes that you can use. Okay, so for today, I'm just going to show you this 3D nuclei segmentation, which would work on images of nuclei which are from cell culture, okay? Not on nuclei that are in tissue, but in cell culture. So if you have images like that, then you can just use this 3D nuclei segmentation. Okay, so you can choose an automatic thresholding scheme here. Okay, I'll just keep the default there. And then, of course, you can choose to do manual thresholding. If you want to, just change this 0 to a lower threshold value. If it's at 0, then it's going to do the automatic thresholding. Then, of course, there's this choice here where you can separate the nuclei. Okay, so if I check this and click on OK, just wait for a little bit. So you'll have to wait a little bit longer if you have a lot of slices in your stack, okay? So immediately you're going to see this image here. This is now your segmented image, okay? There. And how will you measure it? Of course, put it into the 3D manager. So again, because it's segmented, all you have to do is add this image. You can see now that there are some particles here that were already split up, you know, unlike when we did it on the 3D objects counter. This wasn't actually considered as one object, okay? So do the same thing. Open your original image, and then you can select your image and do all the measurements that you want to do on this, okay? So this works pretty well for nuclei, as I said, or maybe objects that actually look like nuclei. What this does is actually, it does a Z projection on your images, and then it applies a threshold in a two-dimensional watershed algorithm, and then extends this into 3D, and that's how it does the nuclei segmentation. Of course, it's not perfect because you can see here that there are some particles that were probably, you know, they were not included in the count, okay? So there you go. All right. The other method under the 3D suite is called simple segmentation. Okay, so if I go to analyze or plugins and then go to the 3D suite under segmentation, you have this 3D simple segmentation. This one lets you input a low threshold. So, you know, if you knew the thresholding from earlier, then you can, you know, plug in the 60 as your lower threshold. You could set a minimum size here. And then once you click on OK, you'll see an additional image. And then you can just add that image and do your analysis on that. Okay, so that's just a simple segmentation. Okay, let's go on to the next. Let's say, let me just close this there. And what if you want to segment this other one here? Okay, so let's say you want to apply your regions to this particular image. So you get measurements where the nuclei are located. So for instance, fluorescence intensities where the nuclei are located. So the original regions that you had here, when you added the image, the segmented image, you will now apply to this image. So you just need to select all the objects here, put ROI to live, okay, and you'll be able to see where your nuclei are located and calculate your measurements, okay? Do your measurements with that, okay? So that's how you can apply your regions to a different or a different channel of your image, okay? So that's all about thresholding.